Hi, I'm Garrett Boudinot, a PhD student in the Department of Geological Sciences at the University of Colorado Boulder. For my PhD, I use organic chemistry as a way to study changing climate and changing landscapes through Earth's ancient history in a field called paleoclimate. When I heard that ISSRNC was hosting a conference on changing cultures and landscapes, I thought that this would be a great opportunity to provide a critical evaluation of the field of paleoclimate through the lens of religious studies, in my talk entitled The Mythmaking of Paleoclimate.
Now, generally, the way paleoclimate works is we identify some interval of Earth history that's experienced climate change. That can be rising sea levels, rapid warming, certain configurations of the continents. And once we've identified one of those, we go and we collect geological archives or records of what was going on Earth during that time period. Now, for more recent paleoclimate events, we can get tree rings or maybe ice cores. But for events in Earth's ancient history, we're left with rocks and sediment cores, like I'm showing here. And once we've collected these sediment cores, we can use a number of analytical methods in mineralogy, biology, and chemistry to get information about the climate system, the biosphere, the atmosphere, the geosphere. We can begin to provide some models of how the climate system works. And we do this because our goals are to identify the drivers of climate change in Earth's past, what has caused climate change in the past, and feedbacks within the Earth system, responses in the Earth system to that changing climate. And we do that with hopes that understanding the Earth system under climate change better will help projections for future climate change. But there are some serious pitfalls with this workflow, because often the causes of these climate change events are not very clear. And moreover, those causes and the feedbacks within the climate system aren't always relevant to what's going on today. For example, in many intervals of climate change in Earth's history, there wasn't nearly as much ice on the planet as there is today, which is an important part of the climate system today. And moreover, the main drivers of modern climate change, such as human land use changes and fossil fuel emissions, were not present in periods of Earth history in the past. Now, to get some of these ideas across, I've chosen a specific interval of Earth history that's often used as one of the best analogs to modern climate change. We've already seen data from that. That's the Paleocene-Eocene thermal maximum. Now, the Paleocene-Eocene is just geology jargon to tell us where in Earth's history we are. As we can see here, that's about 56 million years ago, where sea level was much higher. There wasn't nearly as much ice on the planet. You can see India's yet to collide with the Asian continent. And thermal maximum tells us that it was a rapid warming event. And we see that in the data there, where as soon as temperatures rise, there's a change in carbon chemistry, a decrease in biology suggesting extinctions, and even changes in the mineralogy that might suggest ocean acidification. And some of this data that I'm showing here is from the very first paper to study the PETM, or Paleocene-Eocene thermal maximum, that was published in 1991. So we've been studying this event for over 25 years. And the problem is that in spite of 25 years of work, we've yet to identify the exact driver of PETM warming. And so here I'm showing the 8 hypothesized drivers of this climate change event that is supposedly the most analogous to today. So what this demonstrates is that paleoclimate as it is today doesn't really identify the specific drivers in the Earth system tied to specific feedbacks. Oftentimes, those certainly aren't relevant for the modern climate change. Instead, if you look at paleoclimate literature, it more often resembles a narrative. It generally has some setting, some configuration of the continents and sea level. It describes some rising action and climax and some feedback within the system, and then might hypothesize or describe some return to steady state. But I think that paleoclimate is more than just a narrative. that in fact it functions as a sacred narrative, or what we would call a myth. Now, a myth, as I just said, is a very specific type of narrative, and that's because of the way that it functions. And so oftentimes, myth will function to convey or enforce cultural ideas, values, and worldviews. And in so doing, it provides social cohesion for a community. It provides examples of propriety in behavior. It functions as something sacred, something set apart, exemplary. And importantly for this talk, myth is open to interpretation, or hermeneutics, which allows the fluid and ever-changing interpretation of a myth to stay relevant in that culture. To get across some of these ideas, I've chosen to describe one of my favorite myths, that of the girl who married a bear, which was popular and still is popular amongst native cultures in the southern Yukon Territory. And the version of the myth that I'll describe today was written down by anthropologist and ethnographer Catherine McClellan in the 1970s. And so now I'll briefly describe that myth.
The myth begins with a community picking berries in the summertime. A young girl in the community wanders off a little too far and finds some bear scat by the berry bushes. She proceeds to jump over the scat, curse it, and brag that she's better than the bears. Shortly thereafter, a handsome young man comes and marries her away. She soon finds out that the man is in fact a grizzly bear and has captured her out of revenge for her taunting the bears. They set up a den in the fall, and she convinces her bear husband to set up the den near where she knows her brothers go to hunt bears in the spring. Over the winter, she has 3 cubs by the bear. Come springtime, she makes a ball out of twigs and puts her scent in it and rolls it down the hill so that the dogs can smell it on the brothers' hunt and lead the brothers to the girl. The bear has a dream that reveals to him what his wife has done, and he becomes angry. He debates killing her brothers, but in the end decides to lay his life down for her brothers in the hunt. Before he's killed, he gives his wife rules for how her brothers should treat his body after his death, what they should do with his skin, his head, and what songs they should sing on the hunt. When her brothers have killed the bear, they find the girl and her cubs, bring them human clothes, and slowly incorporate them back into human society, and they turn back into humans. But eventually her younger brothers taunt her and her kids, forcing her to put on bear hide and play bear so that the younger brothers can pretend hunt them. But as soon as she dons the bear hides, her and her kids turn back into grizzlies and end up killing the younger brothers. They return to the woods, and thereafter, the community learns to respect the rules that her husband bear has taught her.
Now, this myth nicely demonstrates how a narrative can convey and enforce propriety of behaviors, cultural worldviews, and norms. But to me, the most interesting thing about this narrative is not the story itself, but the fact that Catherine McClellan recorded no less than 11 versions of this story in 1970. This tells us the power of hermeneutics. Each of these stories was slightly different, given the different narrators' cultural backgrounds, life history, and gender identity. So this myth very clearly illustrates how a simple story can have all of these myth functions. And I argue that this is what paleoclimate ultimately does as well.
And this brings me to my central thesis of today's talk, that the myth-making of paleoclimate is already being used as a strategy to enforce and promulgate preconceived ideas about modern climate change. For the next few slides, I'm going to investigate exactly who is involved in these myth-making strategies and what cultural ideas it is that they're promulgating.
And I've identified 2 main myth-making groups in paleoclimate: scientists and skeptics. For scientists, Myths function as a way to confirm and inform first-order principles of climate change, but always highlight the uniqueness of the narrative that they're telling. So, for example, literature on the Paleocene-Eocene thermal maximum will describe the general warm background state during the Paleocene and Eocene, where the continents were, will provide their main data that shows some first-order change, for example, an increase in temperature leading to extinctions. But will always end with a statement on the specificity of the drivers of this climate change event compared to the modern. Now we can see some of the myth-making power, for example, in just this artwork from a popular science article on the PETM. We can see the symbolic power of some of this imagery. And in this article by Lee Kump, he makes a point of highlighting the difference between the PETM's slow release of carbon into the atmosphere, which we're still not sure where it came from, and the modern fast release of carbon into the atmosphere, where we've identified the driver. Now, the other group of myth makers are the skeptics, and their paleoclimate myth functions to underscore the randomness, the unpredictability, the unknowability, and ultimately the non-human nature of climate change. And I'll provide some quotes from climate skeptics to get this across. For example, New England climate skeptic Michael Sununu has said that regardless of how much climate scientists want to believe we can accurately model the climate, we can't. He highlights the nonlinear, chaotic nature of the climate system and ends by saying they're really just guesses. UK climate skeptic Roger Helmer similarly argues that historical or paleoclimate records reveal that climate change is just natural. Now we can see how these two myths affect American culture by looking at political data over the past several decades. So here I'm showing a plot from 1995 to 2011 of the discrepancy between Democrats and Republicans and their understandings of climate change. And we see through time Democrats' concern about global warming increases, while since 1995, Republicans' concern about climate change generally decreases. And this is problematic because this is during a time of increases in paleoclimate research. And so what we see is that despite a growing body of paleoclimate studies, there's a growing discrepancy in the public of how they understand climate change. And while this study ended in 2011, we see it continuing into 2018, this discrepancy of public understandings of climate change with an increase in paleoclimate studies. And unfortunately, this is not just an artifact of education. While there are slight differences in more and less educated populations' understanding of climate change, they're nowhere near the discrepancy that we see in political groups. So what this tells me is that there's in fact a problem with the current paleoclimate myth. Now, psychologists have worked to help us understand what exactly is this problem with the discrepancy amongst Americans on understanding. I'll summarize the main results into 4 main points. First, that details are important when explaining complex systems. Second, that worldviews guide cognition, something that I'm sure everyone at the ISS-RNC understands already. Third, the importance of framing an idea to fit with someone's worldview. And finally, the role of experience-based learning rather than just description and memorization and helping someone understand something. And I think that all 4 of these main points, these areas for improvement in public understanding of climate change, can be achieved through the power of myth-making. And specifically, I think that requires an alternative hermeneutic. Again, hermeneutics refers to the interpretation of the myth, which can change through time or through culture. And it allows an adaptable and fluid understanding of a myth or making of a myth to adapt with changing landscapes. And I pose the question, what if paleoclimate scientists took ownership of their hermeneutical approach to describing the paleoclimate narrative? I think that would allow a recognition of the power of narrative truth and sacred narrative and the communal consciousness of our surroundings, or in how the public understands climate change. And so I'd like to end with a recasting of the PETM paleoclimate myth under my own words. So I'll begin.
With the coming of climate change, scholars dug into the Earth to ask what we should prepare for. The Earth, in its deep past, had experienced much change, but none like what the scholars predicted. They emerged with this story. 56 million years ago, the Earth was warmer, with higher seas and taller trees, and lacked the cities, streets, polar ice, and computer systems of today. There were no humans at all, only the humans' ancestors who lived with the other animals and plants in great numbers from pole to pole. It was a very different place. The climate had been warm yet stable for millions of years prior. Then, temperatures began rising quickly, enough that the plants and animals were affected. They did not come together to try and identify why things were warming. What good would that have done? They could not, as individuals, change the warming. Whatever the cause, it was larger than the power of their small communities. The combination of the methane, volcanic carbon dioxide, and solar forcing corporations had set their course to warm the Earth. Recognizing this, the communities on Earth decided to change. Plants began to grow differently, working to sequester the atmospheric carbon by requiring less nutrients from the soil, such as nitrogen and phosphorus. But because animals require nutrients like nitrogen and phosphorus, they had to eat more plants or learn to get by with less. The insects decided to eat more. The mammals, humans' ancestors, went a different route. They reduced their resource needs. They got smaller. They found that getting smaller kept them cooler as well. For many animals, changing consumption or size simply was not enough. Climate migrants found refuge at higher latitudes and new continents. Certainly, these migrations led to changes in local ecologies and community interactions, but they were necessary for the equal survival of land animals. Indeed, humans' ancestors likely survived because of their ability to freely migrate. Changes in weather led to stronger, more erratic storms, which certainly wiped out communities and led to more migrations. The oceans felt the greatest destruction. And the deep ocean, warming and acidification led to the demise of some communities. Scholars tell us that this destruction is because of the rate of warming. These communities would have been spared if the combination of the methane, volcanic carbon dioxide, and solar forcing corporations had been slower. Suddenly, almost as soon as the warming began, which was tens of thousands of years, it ended. The combination of the methane, volcanic carbon dioxide, and solar forcing corporations could not continue forever and eventually used themselves up. Those communities that adapted were better off for it. Mammals, having gotten smaller, relied more heavily on each other for protection. Their relationships got stronger. Plants, having put more carbon into the soils, then had more fertile, carbon-rich soils to promulgate from. And those communities that did survive in the deep ocean thrived because they were more resilient. Those that died off are still commemorated by the Earth and those scholars to this day. If you look closely in the rocks, you may find them, and too, learn their stories. With that, I'd like to thank the ISS RNC leaders and conference organizers for letting me give this talk on the online platform, to all the funding sources that have helped my PhD move along, to Todd Lavasser, who's given me helpful comments and encouragement with this talk, and particularly to Zero Load Productions for helping me film this in beautiful Jamestown, Colorado. And finally, to you, the listeners. Hopefully this will begin a great conversation through the comments we have online. Thank you.
We'll have to keep that. Yeah.